Have you ever wondered what lies beneath your feet? Not just beneath the soil or the rock, but far, far deeper. Picture this, you're standing in your backyard, and with each passing moment, you begin to sink slowly through the Earth's crust, down through miles of rock, into the fiery mantle, deeper than any machine has ever gone. The light fades, the pressure builds, the temperature rises, and eventually, you reach a place so alien, so extreme, it might as well be another planet. Welcome to the Earth's core, a world we can't touch, but one that shapes every moment of our lives. It's easy to forget that we're living on a sphere of molten metal, cooled only on the outside. The Earth is like a peach, a thin skin on the surface, a fleshy mantle, and deep inside, a dense, blazing hot core. But unlike a peach pit, the Earth's core is not just sitting there doing nothing. It's alive, in motion, and incredibly powerful. It creates our magnetic field, it drives earthquakes, it fuels volcanic eruptions, it protects us from the harshness of space. Without it, life on Earth wouldn't exist. Yet for centuries, the core was pure mystery. No one had ever seen it, touched it, or come close. The deepest hole humans have ever drilled, the Kola super deep borehole in Russia, reached just over 12 kilometers. That's not even 0.2% of the way to the core. If Earth were an apple, we haven't even scratched the skin. So how do we know what's down there? The answer lies in earthquakes. Every time our planet trembles, it sends out waves that ripple through the Earth. These seismic waves bend, bounce, and change as they travel through different materials. Scientists began studying them closely and discovered something extraordinary. They could use these waves like sonar, like doctors using ultrasound to see inside the body. This technique, called seismic tomography, lets us peer into the Earth's interior in stunning detail, creating 3D images of a place we'll never reach. Through these techniques, we've learned that the Earth's core is made of two parts. The outer core is a vast ocean of molten iron and nickel. It churns and swirls constantly, creating electrical currents. And those currents, they generate our magnetic field, an invisible, vital shield that wraps around the Earth, deflecting dangerous solar radiation and protecting our atmosphere from being stripped away by solar winds. Inside the outer core lies the inner core, a solid sphere made mostly of iron. It's about 1,200 kilometers in radius, roughly the size of the moon. But this isn't just a big metal ball, it holds secrets of its own. Scientists have discovered that the inner core isn't uniform. It has complex layers and surprising behavior. One of the strangest discoveries? The inner core is spinning, and not at the same speed as the rest of the Earth. This phenomenon is called superrotation. Imagine Earth rotating once every 24 hours. Now imagine the inner core rotating slightly faster, gaining a few degrees every year. It's as if the heart of the planet has a rhythm of its own. Why does it do this? Scientists think it's linked to the magnetic field, the very force that this core is helping to create. But that magnetic field isn't as constant as it seems. It flickers, it shifts, and sometimes it even flips. The north and south magnetic poles have reversed many times over Earth's history. These geomagnetic reversals are rare but dramatic. The last major reversal happened about 780,000 years ago. If it were to happen today, it could wreak havoc on satellites, navigation systems, and even wildlife. Some animals, like birds and turtles, navigate using the magnetic field, literally sensing the planet like a built-in GPS. Scientists are still unraveling how they do it, but it's one of the many signs of just how intimately life is connected to this hidden world beneath us. But the core does more than just create a magnetic shield. It powers the engine of plate tectonics. The intense heat from the core causes the mantle to churn in slow, colossal currents. These currents push and pull on the Earth's crust, breaking it into plates that float atop the mantle. Where they collide, mountains rise. Where they pull apart, oceans form. When they slip, earthquakes erupt. When they melt rock, volcanoes explode. The energy that breaks apart continents and creates new land doesn't come from the sky, it comes from deep below. And yet, the core itself is still changing. New research suggests the inner core may be shifting unevenly, with one side growing faster than the other. It might even have distinct hemispheres, a west side and an east side, each behaving differently. These findings challenge our long-held views and suggest that the core is not a frozen relic from Earth's formation, but a dynamic system still evolving today. In a way, studying the core is like decoding the biography of our planet. It holds the story of Earth's formation, its geological past, and maybe even its future. Scientists are now using supercomputers and simulations to model what's happening thousands of kilometers below us. They're finding clues about how the core affects everything from earthquake patterns to climate over geological timescales. And perhaps the most humbling realization? The Earth's core may be the reason we're here at all. Without it, the magnetic field would vanish. Solar radiation would strip our atmosphere. The oceans would evaporate. Earth might resemble Mars, cold, dry, and lifeless. It's a silent guardian, working tirelessly beneath our feet. So next time you feel the ground beneath you, remember, it's not just solid rock. It's a gateway to one of the most extraordinary places in the universe, a place we'll never visit, but whose heartbeat shapes the world. Thank you for joining us on this journey to the center of the Earth. If this video sparked your curiosity, don't forget to like, subscribe, and hit the bell icon. We've only scratched the surface of what's happening beneath it. Until next time, stay curious and keep exploring.